Very good afternoon, dear participants. We'll just start up our session in few minutes. Just in 2 to 3 minutes, we'll start the session. Good afternoon, dear participants. I'm Manasa Vatsavai, Assistant Professor of Civil Engineering Department at Sri Vishnu Engineering College for Women, and I'm the coordinator of this program. First of all, I thank you all for being a part of our one-week international student and faculty development program on role of transportation engineers towards sustainable roads and traffic safety, which is organized from 22nd February to 27th, that is today. And this is the last session of ours, and this session is going to be addressed by Dr. Pala Girish Kumar, Associate Professor and Head of the Civil Engineering Department, Sri Vishnu Engineering College for Women. And now I request Mrs. P. Lavanya of Civil Engineering Department to introduce him. Madam, please come and introduce him.
Thank you, Mansa. Thank you for giving this opportunity. Good afternoon, one and all. So, firstly, I welcome all the dignitaries and the respected faculty and my dear students to this virtual platform. Now, I would like to introduce the session speaker, Dr. Pala Girish Kumar, sir. So, Dr. Pala Girish Kumar has obtained his BE Civil Engineering from Sri Venkateswara University College of Engineering, Tirupati, India in 2012. And Masters in Transportation Engineering and Management from National Institute of Technology, Tiruchirappalli, India in 2014. And PhD in Civil Engineering from National Institute of Technology, Tiruchirappalli, India in 2018. He worked as an assistant professor at Gudlavaleru Engineering College prior to Sri Vishnu Engineering College for Women, SVECW Autonomous, from 2018 to 2019. In 2019, he joined as an associate professor in Sri Vishnu Engineering College for Women, Bhimavaram. And at a Versanier age, he has been delegated as the head of the Department of Civil Engineering at SVECW. Dr. Pala has guided one MTech dissertation and 15 UG projects in the areas of pedestrian traffic, self-healing pavements, simulation, route optimization, RAP were guided by him, and many more are on board. Apart from that, he has been invited as a keynote speaker by multifarious institutions, organizations, and AICTE sponsored programs as well. Besides all the technical aspects, Dr. Pala sir has been the rock solid performer in the area of administration and external affairs. He is the prime mover and instigator of Royal Civil Collegium Club RCC, established in the year 2019, whose cardinal motto is to expose women students in the technical and industrial aspects of working areas. Dr. Pala has also been the founder of the Career Development Program, CDP, in SVECW that functions in indulging technical and non-technical skills. He also restarted the Indian Concrete Institution, ICI, student chapter in SVECW and wrapped the Outstanding Student Chapter of Andhra Pradesh 2020 award from ICI Vijayawada Center, Ultratech. He holds a lifetime membership in professional bodies like the Indian Geotechnical Society, IGS, and Institute of Engineers, AIME, India. In addition of all these institutional flourishments, he had organized several workshops for faculty and students and has been consistently working on various virtual programs like String Webinar Series, Digital Wing 2K20, an online events platform, short-term training programs, STTPs, AICTE-sponsored programs. In recent times, Dr. Pala successfully organized a prestigious national virtual conference, SATACE 2020, on sustainable construction technologies and achievements in civil engineering, and was the mastermind behind the milestone success of the conference. Besides all, he was honored with a national award from the government of Tamil Nadu for the best project during the year 2014. Best paper award received for the paper presented in International Conference FEAST 2018, NIT Trichy, and also won the International Best Researcher Award of the year 2020 in the area of terra mechanics and nanomaterials in pavements from Edamas Learning Center, Malaysia, and World Research Council, WRC. Apart from being an active facilitator, he holds the stance as National Advisory Committee member in International Conference on Advancements and Innovations in Civil Engineering 2021. Dr. Pala was induced as an editorial board member of Journal as reviewer in Science and Engineering and also a reviewer of the Transportation Research Board, TRB, International Journal of Engineering Sciences, Advanced Computing and Biotechnology, Global Journal of Research in Engineering, USA, Silicon Journal, and two more journals. He has blazoned 18 publications at international conferences, 15 plus at national conferences, 30 plus publications in well-reputed international and national journals, and a monograph titled Speed Detection and Management in ITS Applications with Lambert Publishers, UK, and accounted to two book chapters as well. Dr. Pala's areas of interest relates to terra mechanics and nanomaterials in pavements, traffic safety, pedestrian and driver behavior analysis, self-healing pavements, pavement evaluation, and management and traffic simulations. As a faculty member and on behalf of students, we all are blessed to have such a versatile HOD. I request our beloved HOD, Dr. Pala Girish Kumar, to take over the session. Thank you, sir.
Thank you very much, madam. Can you confirm me with your my voice is audible to you?
Yeah, yes, sir.
Yeah, I'll share my PPT, then I will go into the session. Yeah, I think this is visible to you all of to all the participants. A very good afternoon to one and all. So, thanks to Mrs. P. Lavanya for the nice introduction. I hope my voice is very clear.
Yes, sir. Yes, sir.
Yeah,
Yes, sir.
thank you. For a better experience, I'll stop video so that maybe my voice is will be very clear without any breakage. So for the past 1 week, we experienced a lot of expertise talks from various experts uh, across India, as well as from local experts as well as local experts. So in the various areas like payment management system or payment problems, we experienced on various talks on road safety and traffic management system. And today morning, we have seen something regarding the pervious concrete payments as well as payment asset management. So on a whole, we understood the necessity of the topic, safety, as well as the payments, which plays a crucial role to provide a comfort to the road users, and therefore it gives a sustainable life as well as a best traffic, best transport usage. So apart from this, today in my lecture, I would like to just give an insight on how this remote sensing and JS can be applied for as an application in various problems, and exclusively I'll try to give insight of how we have applied this RS and JS application in one of the case study. A couple of the participants I could see might be attending the same presentation. So maybe the people who have joined newly can get the insights more. But before going to the session, I would like to just give a brief intro of how this project is taken up and what is the necessity of doing this kind of a project. So this is the case study which was conducted during the year 2013-14 during my master's program with the help of government of Tamil Nadu, especially Trichapalli Municipal Corporation. And as we all know, we have to conduct a master's project research. So unlike other projects, I thought of doing a live real-time project. So at that time, the government of Tamil Nadu have sanctioned a big amount of fund towards its infrastructure development during the year 2012-14. So as a part of it, in Trichapalli Municipal Corporation Commissioner sir is very much keen to very much keen to develop non-motorized transport facilities in an area where he is born, in Trichapalli. So when I met Commissioner sir and I was asking him what is the government projects that are undertaken right now, and I would like to take up the project and want to work on it and submit to the government. So as a part of it, he was explaining a couple of projects like the NMT facility and bus rapid transit system BRTS. So that is what they are initially planning to bring it to Trichy as a part of that infrastructure development fund. So fortunately, I had this communication, and they were accepted that for accepting like taking me as a part of that project and giving me a task and to giving me a year to submit a proposal. So that is how actually the project has taken. And later on, it is identified huge number of road accidents are taking place because since lot of pedestrians, lot of cyclists, lot of rickshawala, and moreover the area is comprised of lot of schools, lot of colleges, and the residential buildings where people most importantly involved in this NMT non-motorized transport. So therefore, the project is much more utilized there, and hopefully they are implementing this in different phases. Hopefully, this phase one is completed so far. So that is the research that we carried out and would like to share this here. So very recently, I was invited with one of the college to give a talk on geospatial approaches. So then I thought of doing this case study, using the RS and JS application to find out the cost for it. So ultimately, we were able to find out the hotspot places, like the hotspot regions using this RS and JS. Therefore, we were able to collaborate, interlink these two. Like the research work carried out in the past and currently use this RS and JS application towards identifying the hotspot regions as well as identifying the land use, land cover changes over years. So with this intro, I will just try to show my the course content, which I'm gonna express in this presentation. So I would like to talk a little on the introduction of the remote sensing and introduction of JS, and later I will talk other applications which were used with the JS and RS in various fields apart from transportation. And then later I will talk about how this RS and JS was applied to identify hotspot regions for my case study. And later I'll show the actual case study which was carried out in Trichy during the year 2013-14. That is, the main intent of the project is to provide cycle tracks in 4 different areas of Trichapalli. And then in that, particularly, we were able to identify the existing road, comfort levels, which is a level of service based on the speed, travel, delay, as well as maneuverability and safety aspects. And then we were able to develop a bicycle compatibility index model, which is absolutely to give how best the bicyclists are getting comfort, including the mixed traffic. And then the simulation was carried out in order to validate the results which were obtained from the model as well as from the field survey. And fortunately, we were able to get the best results, and therefore the proposed model is best fit to develop in the selected roadway segments. Then I will show you some of the conclusions of the study. So with this, I will try to go with the introduction. So let us have a quick look on what is the remote sensing and JS. So I see a lot of students and a couple of faculty are present in the session. So if I ask you anybody to define, many of us might be saying quickly the remote sensing is the science or the art of processing or obtaining the information about any object or a phenomena, or the analysis that you do without getting in contact with those things. Or simply you can even define this remote sensing is a process of sensing or measuring the objects from a distance without in physical contact with them. So most importantly, the sensors are used to collect the data in order to analyze on like different features on the Earth's surface, how it emits or reflects electromagnetic energy. So finally, the remote sensing is something that process that collect information without in physical contact with those features. So we should also know what is the importance of this RS and JS. When you talk about the importance or significance, or we have a lot of importance and as well as significances. Among all, if someone wants to collect the large amount of data, and this is where you need to look into it. RS is the one platform where you can get a large amount of data, and this reduces ultimately the manual field work dramatically. And maybe if you go further, if someone wants a data which is from a difficult regions, this is where you can look at this remote sensing can allow anybody to retrieve the data from regions of difficult. Just give me a second, please. Maranam, sign this. Please excuse me. So we are talking about the second important significance of remote sensing when somebody wants to retrieve data where from the difficult regions or impossible to reach. For example, you talk about open oceans, or you talk about the atmosphere, you talk about the ocean depths, or you talk about open oceans or hazardous terrains like high mountainous regions or extreme weathering areas and so on. So this is another important factor which can be taken as an important thing from aspect from remote sensing perspective. Also, if you go further and even somebody wants much more data in a shorter amount of time, and this is where you are going to use remote sensing to get the large amount of data in very short amount of time, and this leads to increase land coverage as well as to increase ground resolution of a GIS. And one more important factor for this in this remote sensing is digital imagery that which can greatly enhances the GIS directly or indirectly. When talk about this direct, the imagery can serve as a visual aids, or indirectly it can serve as a source to derive the information such as land use or land cover, or the atmospheric emissions, or the vegetation, or water bodies, and so on. When you talk about the stages or the process or the steps involved in remote sensing, you can see the picture that shows from right from source to the information. So for example, you see here different stages and steps in remote sensing that are involved. So for starting with the source, the energy source or illumination, to the radiation and the atmosphere that is atmospheric interaction, and then the target, and then the recording from the sensor, and then transmission and the processing to the processing unit and receiving unit, and therefore the interpretation and analysis takes place with the processing unit, and then the application and the analysis would do from the information unit, where you can see in the form of map or a GIS or a decision making. This is how these different steps or different stages of the process involved in the remote sensing. So when you talk about the types of remote sensing in general, the remote sensing is classified based on two types. One is based on the source of energy. One is the electromagnetic spectrum. Based on the source of energy, the remote sensing is further classified into two types. One is the passive remote sensing. The another one is active remote sensing. So again, when you talk about the passive remote sensing, again, it has having two classifications, lidar and radar. So this passive remote sensing is which measures the energy that is naturally available, is nothing but the passive remote sensing system. When you talk about the electromagnetic spectrum, which is based on this, the remote sensing are classified as three. One is the optical remote sensing, one is the thermal remote sensing, one is the microwave remote sensing. And when you discuss about the optical remote sensing, the optical remote sensing is further classified into two types, and this is absolutely based on the spectral bands that are used. So one is a multispectral imaging system, and the other one is superspectral imaging system. So this is how this remote sensing is classified. So you are able to know what is remote sensing, and then what are the steps involved in the remote sensing, different stages, and the importance of remote sensing, significance of it. And then we have seen the types of remote sensing in general based on the electromagnetic spectrum as well as the energy source of energy. And then now let us see quickly about the GIS. So before that, we should understand what is geography. So you see the picture. The geo is nothing but the earth, and you see here, this is nothing but the study of the earth and where the things are. It could be anything, any feature or any phenomena, whether it could be a natural or artificial, right? So now you see this geographic plus information plus systems. We call this as a geographic information system. If you go further and discuss about this, you could see this geographic information system is something deals with capturing, deals with storing, deals with manipulating, deals with interpretation, deals with visualizing, deals with analyzing. So completely we can say this GIS is a computer system for capturing, storing, checking, and displaying data which are related to the positions on the Earth's surface. As a whole, we can tell that GIS is something, it's a conceptualized framework which could talk about the data that could be a spatial data or geographic data. So now, so if you see this slide, it is saying the computer systems and programs that helps answer questions about the world. That's all about GIS. Right. Now you see the picture, this clearly shows us something. So GIS is describing our world. So there is a tree, there is a globe. You can see we can describe any element of our world in two ways. One is the location information, one is the attribute information. You're going to know where is it, about the location, that is coordinates, latitude, longitude, altitude. So you're going to know about the information. You're going to identify it. That is the attribute information. What is it? It may be a height, it may be age of that, it may be the condition of the tree. So this as the tree is an example in this slide. So this is how this GIS can describe our world. So finally, this GIS can show many different kinds of data on one map, such as the streets, buildings, and vegetations. If you see this slide, this GIS is having different components. So basically, this GIS is integrated with hardware, methods, people, data, and software. These are the 5 important components that GIS is integrated with. And then, yes, this is what GIS can do. This can try to model anything that is available on the Earth's surface. So if you see this slide, this clearly shows the different processes that a GIS can build. That is, the GIS can analyze, the GIS can visualize, you can plan, you can do decision making, you can store the information, you can collect more information, you can prepare a map, and then I hope everyone knows this free GIS software, that is ArcGIS, that can be used to do various research works. And what can we do with the GIS? And if you ask me, I can show this. Yes, we can make maps. As we mentioned earlier in the slide, we can map charts even. You can see different examples given, like transportation map. Say different charts are also given. This is prepared using GIS. And what else can GIS do? Yes, this can even put information, important information on maps. Maybe about the streets, maybe about the buildings, maybe about the vegetation. So it can put different important information on maps. like different layers. See, the information is nothing but the things that are available in the real world, which is the land use, streets, districts, land parcels, and so on. And see this is another slide showing the important information that is organized in different layers, like polyline or a polygon or a point data. So basically, we have a GIS in terms of a vector data or a raster data that we will see in the coming slides. So this is how this GIS information is organized into different layers. What else can a GIS do apart from this? This can answer your question. This can answer any kind of questions that you have. Yes. For example, a couple of questions are mentioned here. Where was the last earthquake has taken place? Or the population of people in India. So this is where the GIS can really help in answering all the questions that the world have. Okay. So now we'll see the various applications we can use for using GIS to solve in the real world. So these are the various examples I have mentioned, right from energy forecasting to air quality. So GIS can be applied in order to analyze these different applications like energy forecasting. It can be used to do the disaster management, or it can be used to analyze the water management, or it can be used to do analysis on the air quality and so on. This is how the GIS can be used or utilized in various applications. Still, what else can a GIS do? Yes, there are a couple of examples mentioned in the slides. You see quickly. It can help to plan a city or urban planning. It can even show a virtual city. It can even helpful for doing land use suitability analysis, or it can even do help in managing the land by doing this integrated land management or mapping or a property evaluation, or the GIS can help to work on public safety, work on the fire response, work on the crime analysis, or it can even help to manage natural disasters like or the earthquakes or the flood simulation or the wildfire. So all this can be GIS can be used to work on these applications, or even this GIS can help to manage electricity, water, and phone. You can see the pictures where the different networks are shown, highways, and maybe you can see this model transportation application using GIS, real-time traffic and ride-share analysis, transit analysis can be done using GIS. And also you can work on the earth science and water resources like seismic hazards and flood risk analysis using GIS, and also online soil parameter identification using GIS. So these are the things that people can use GIS to work on for a real world problems. Like even you can work on GIS to monitor climate and energy. These are the examples of how GIS can be used to do the analysis. So finally, I would like to tell this GIS can be used for any kind of specialization, irrespective of remote sensing or GIS in civil. So this is how this remote sense GIS can be used to also do a work on impact of global climate change. So these are the different countries, so with different applications. So now this is all about how this GIS could be applied on various applications, irrespective of the specialization, according to your need. So with this quick introduction, I will try to go with the case study that we carried out. I hope that you are able to see this slide now. So how this RS and JS is applied for my case study in order to find out the land use, land cover change, as well as to find out the hotspot regions. So to find out the hotspot regions, we were able to do this IDW interpolation. This IDW interpolation is the inverse distance weighing interpolation method, which is used to identify the hotspot regions in that particular area. So basically, we use GIS as well as remote sensing. So we were able to develop the thematic map layers by giving the spatial data and non-spatial data from the vector layers. So basically, we took the boundary map and road map. We were able to feed this decadal accident data, where this boundary map is nothing but the administrative boundary map of the study area, Tiruchirappalli, and the road map is taken from the high satellite imagery data, high resolution satellite imagery data. And the boundary is nothing but it is the polygon. You can able to see in the picture that I show that is a polygon that is showing this boundary map, and this is the polyline in the road map. And the point data is this decadal accident data, which is feeded as a spatial data. So we were able to also feed the non-spatial data, the information of this accident, like suppose it is whether it is a cyclist, or whether it is a collision, or it is a fatal accident, or it is a two-wheeler with a four-wheeler, or two-wheeler to two-wheeler. So like this, the complete information is given as a non-spatial or identity about the accident. So finally, we were able to develop the thematic maps, and from that thematic maps, we were able to do collect event analysis and then hotspot analysis. From that hotspot analysis, the output which we obtained from the hotspot analysis is given as an input to this IDW interpolation technique. Therefore, we were able to identify the hotspot regions, and later on, this remote sensing we have used to identify this land use, land cover detection. So this three data is taken, which is a satellite data for the 2010 to 2014, and then layer stacking has been done. The layer stacking is nothing but this is the process of combining multiple images into a single image to make it a multispectral image. Okay, we generally having single images as a black and white images. So we clubbed different images together to form a multispectral image, which is a color image. And later on, we went through the unsupervised classification. Though we can also go for a supervised classification, we preferred unsupervised classification since we want to make it a more accurate. So we chosen this unsupervised classification, and then we again go for a decoding it. Because this when we opt for unsupervised classification, the data by default it will be taking and assigning lot of classes. Suppose say it will assign 10 to 15 classes. So maybe even if you take a color like a dark blue and light blue also will be considered as the two different classes, where for example this blue indicates a water body. So later on we done this decoding in order to make that dark blue and this light blue bring two into one class as a water body. So that is why we did this decoding after this unsupervised classification, and then we have able to find out what is the land use and what is the land cover. That we were able to change, like we were able to detect the changes. So finally, using the GIS, we were able to identify like the spread of accident zones, or the maximum number of accident zones that were happen in the selected study area. From the remote sensing output, we were able to understand the maximum number of settlements taken place over the years, right from 2010 to 2014. So land use is nothing but the residential buildings or something. Land covers is something that is naturally available. So this is the LULC we were able to see, and we were able to witness the change in this LULC. So this we will be showing in the coming slides. If you see this picture, this picture represents the study area map in Trichy district, Tamil Nadu, India. So you could see the area of interest AOI here, which is this boundary is Tamil Nadu, and this is this boundary is Tamil Nadu. This is this red boundary is a Trichy, which is our area of interest. And now you see this thematic layers which were developed. So this is a road network, which is a map. The map is which is a map, which is the map is nothing but which is a 2D representation of different data, which is nothing but a map. You can see the road network map of Tiruchirappalli, Tamil Nadu, where you can see the red lines which indicates roads and the black indicates the boundary. So this is including the base map of Tiruchirappalli road network with the base map of Tiruchirappalli, Tamil Nadu. So you could see the roads and the boundary with the base map. And later we were able to do that digitizing the roads. So we were able to classify the different roads, right, from collector street roads, or major roads, or minor roads, and street roads. So you could see this, the legend which is presented in the bottom of this, the first map, the map showing the category of roads of Tiruchirappalli, Tamil Nadu. So you could see this thematic layer. And then on the right side, you can see the decadal accident data which is given, which is feeded into this thematic map. You can see the point data. All these are the point data. We will be showing the information about the accidents in the region. If you see the fatal crashes, that indicates in the red color, or the injury crashes, that indicates in the green color, or the PDO, the property damage only crashes, indicates in the yellow color, and the black color indicates the roads. So this is the different. This is the non-spatial data along with the spatial data which is given. You can see in the in this map in the decadal data showing severity of accidents of Tiruchirappalli and Tamil Nadu. And now, and we have done two things here. One is the kernel density analysis and then IDW interpolation technique. This kernel density is something which calculates the density of a point features around each output raster cell. Maybe if I can show you a picture, you will understand this. This is the curve that this kernel density function involves to make you very like understanding clearly that I can say this kernel is something that really tells us how dense the accident points are taking place, like how dense the accident points are happening at a particular point at a particular area. So that is why this kernel density analysis have done, and with this we were able to identify these hotspot regions right from least density to very high density. If you see this point data, you can able to see these different clusters. You can see this red zone. This is having a huge severity of accidents that are happening in this Tiruchirappalli, in this area. So this is the map that's showing the kernel density function determining the accident prone areas in Tiruchirappalli, Tamil Nadu. So this is how it is given. You see right from very high density to least density. Dark red indicates the very high density, and dark green indicates the least density. So this is the spot where it is having a huge number of conflicts comparatively to another different areas of that Tiruchirappalli city. So after this, we were able to do this hotspot analysis. Prior to this hotspot analysis, we did this collect events where you're going to assign the values for the points. For example, you're going to give a grouping and you are going to give up different classes. For example, you see here, you can see a 5 to 6 range giving a very big circle here. Similarly, if you see the legend 4 to 5, you are given, you can notice some kind of a circle with a lesser size compared to the previous one. And if you go through these 3 to 4 points, and this is another circle which is very less compared to the previous size. So the meaning of this is to is nothing but this is the way we assigned the accidental points. For example, you see couple of points are taking like these points are representing the accident spots. So the accidents are taking place with a very minimal distances. With very minimal distances, the different points are you can see in the picture. So that is given with a very big class, like very big circle. And later on, you can see the points which are very far away from the accident points, and we have assigned this with a lesser size. That is how this is classified in collect events. And then this output is given as an input to the hotspot analysis. And this hotspot analysis could able to give the cold spot regions. Like you could see in this picture, this is the hotspot analysis on the accident locations in the study area. If you could see this Tiruchirappalli map, you could able to see this red zone where you can see different clusters all together, which represents the hotspots, the 99% confidence, the confidence that you are seeing, the huge amount of conflict that you are able to see here, witness here. So this is how this hotspot analysis is done after the collect events. And then with this, we were able to do this inverse distance weighing interpolation. This is the method this is the method that we were able to adopt, and we were able to assign different weights. As I mentioned in the previous slide, we were able to give here we were able to assign different classes like circles. This with a range like 5 to 6 and 4 to 5 or 3 to 4 or 1 to 2. Like 1 to 2 events are happening with a large amount, with a wider distance. So we have assigned this symbol, and 2 to 3 events together happening at a quite very short distance compared to the previous day. So we have given this kind of a size. So similarly, in this IDW interpolation technique, we need to assign different weights. So these weights are given based on the number of accidents taking place at a point. So if the point is away from the accident area, So you are going to assign that point with a lesser value. So if you see this, the yellow color, dark yellow to dark red, so you are seeing the least possible value is -2.699, and the maximum value is 4.03, which is a positive. So you're able to understand this is the weightage that we were able to assign to the different points based on the distance that is that is existing, which is quite away from the accident area. So we were able to give a more value to the points which are very close to the accident zone. So finally, we were able to do this interpolation distance, inverse distance weighing interpolation method in order to identify this hotspot regions. So with that, with that vector data, we were able to identify the hotspot regions in this particular study area, which is a KK. I'll quickly show that study area in the coming slides. And now that's all about the vector data. And now that is all about the JS, how we have developed and how we have identified the hotspot regions using lateral density function, as well as hotspot analysis, as well as IDW interpolation technique. And now using remote sensing, taking the list 3 data, we were able to do layer stacking first. That is what I mentioned, like, it is nothing but the process of combining various images into to make a single like multi-layer, like multi-colored spectral image that shows phenomena like vegetation or water body or urban buildup or rural buildup and so on. So this is the basic data, basic list 3 satellite data, and after this we were able to do this layer stacking, and then we went for the unsupervised classification, and then later on we were able to recode that unsupervised classification into water body, into connectivity, and into vegetation, and into built up, and into scrubland. So if you see these 2 pictures, one is for 2010 and one is for 2014. So in the bottom, if I mentioned one table, and this table gives the land use land cover details. You take the water body, you can see the change in water body from 2010 to 2014, and maybe you can see the connectivity, which is roads or rails or railway lines or roadway network, so like that. And maybe you can see vegetation, or you can see the urban buildup or rural buildup, and so this is how we were able to witness the rise in the in area under the buildup. So if you see 2010, you are having 2,554 hectare areas, whereas the urban buildup has risen, increased to 2,952 hectare areas, which is almost 15.61% increment from 2010. So which means there is a huge settlement has taken place in different area. I mean, this as an urban buildup. Therefore, what happens? Therefore, the traffic increases, the congestion increases within the available space. So therefore, ultimately, different conflicts used to take place. So therefore, you can go with different proposals in order to develop the safety for the people who are living in that area. So this is how we were able to correlate this remote sensing and JS application with our case study, which was already done in the past, and also we were able to understand, yes, this is the way the proposed proposal also may be useful to the people in that area. So now with this, I will try to show actual case study which is conducted in the Trichy during the year 2013-14. So the main intent of this case study is to provide a cycle track in urban arterial roads, which is a case study of Trichy. We were able to select, as I mentioned clearly, this is a complete project, which is a real-time project, which is taken from the Municipal Corporation of Trichy, Tamil Nadu. And later, this RS and JS is just developed in order to show the participants how this RS and JS can be applied for various kind of research work, with an example of this case study. So we understood that cyclists are most vulnerable, and that the roadway characteristic varies across different places, and we definitely need a safe and convenient and well-designed facilities in order to accommodate the existing traffic, as well as the future traffic demand as well. So we have selected this study area as a case study, which is a KK Nagar, which consists of 4 roads. One is Sinkometer Road, one is Race Course Road, one is Rajaram Salai Road, and one is Kajamalai Road. I will also show you the length of each road stretch in this coming slide. So, most importantly, the main aim, as I mentioned, is only to provide or to design a cycle track on the stretch of KK Nagar, comprising all these 4 networks, where you can see large number of schools or large number of colleges and the huge residential buildings are. Most importantly, the people who are living in that area are preferably opting non-motorized transport. So that's why we were very much interested to introduce this facility towards its a sustainable or sustainable sustainability or good road safety. So so the second objective of this case study is the bicycle level of service, which we were able to find out for the existing roadway, and then we were able to also obtain these BLOs for the proposed road network. And we developed this BCI model, which is a bicycle compatibility index model. I'll tell you what is the level of service as well as what is this bicycle compatibility index and what are the parameters that are involved with this by BCI as well as BLOS. And most importantly, this BCI is developed to understand the compatibility of road to the bicyclist with the existing mixed traffic condition. And then we are able to simulate the traffic condition for the existing traffic as well as for the proposed traffic scenario, and we were able to get the fruitful results, and therefore we understood that the proposed network can be suitably applied and implemented in the selected area. So if you ask me level of service, you can, this level of service always gives a quality measure which is used to relate the quality of traffic services. And maybe this level of service is classified from A to F with the different ranges based on this speed, based on the volume to capacity ratio, or based on the delay, or based on the safety, or based on the maneuverability, and so on. So our interest is here to define the bicycle uh, level of service. Give me a second. I'd like to drink water. So basically, we would like to just define the bicycle level of service. Prior to that, we will see what is the work initially conducted in order to go for finding the level of service as well as to develop the BCI index. So firstly, as we are aware, whatever the work you do in the transportation, first most important thing is to do this traffic study. So we were able to collect the traffic volume composition across different roads during peak hour as well as non-peak hour, in morning and afternoon and evening. So this is how we have classified the various categories of transport, like bus, minibus, truck, car, auto, jeep, van, or two-wheeler or cycle. You can see the amount of percentage of the vehicle composition that is sharing in the particular road stretches for race course road or a Sinkometer road, as well as the two other roads, Rajaram Salai Road as well as Kajamalai Road. So most importantly, if you see, so people are using majorly using the two-wheeler. Wherever you see in this traffic volume composition, you see the majority is two-wheeler, and then therefore maybe cycle people. It's almost 8% to 10% people are using cycles, and also public transport is almost around 2%. So that is a bus or minibuses. So we were able to understand that 10% of people are using non-modal transport. So therefore, there is also another case study which is done by another colleague. He has done on the road accident study. So from that, we were able to understand the huge number of conflicts are used to happen in this selected roadway. So therefore, we got much more confidence to work on this proposal, and therefore we were able to get a fruitful results in the proposal also. So after this traffic composition, we were able to also do this spot speed analysis in order to understand the speed of the bicycle users on the selected roadway segments. So you were able to see this, and you were able to find out the speeds of the cycle users. You were able to obtain the 85th percentile of this, as well as 90th percentile of this. So majority of people are going with speed, common speed. So these are the different graphs. So now let us see what is this bicycle level of service. This is of our main interest. This BLOS is defined as a comfort level of various cyclists would experience while riding on the selected roadway segment. Or simply you can tell this BLOS gives the quality of service for a bicyclist that currently exists within the roadway segment with existing environment. So therefore, this BLOS has the different ranges and is given different grades from A to F, where the level of service A indicates a best roadway condition that one could able to ride their cycle, which is the best, most suitable roadway segment for a bicyclist. The level of service F indicates the roadways that are most or least suitable for a bicyclist. So this expression, if you can see, there are different parameters involved in this, right? From average daily traffic, directional factor, peak hour to peak to daily factor, peak hour factor. So we were able to identify and measure all these things, and we were able to find out the bicycle level of service for the existing road networks, for the selected roads. So if you see these different ranges of how this bicycle level of service is given, this bicycle level of service are ranges as follows here. If you see in the slide, the table, yes, if you see this less than or equal to 1.5, which is represented as level of service A, which represents excellent bicycle environment, and B, if you could see, it ranges between 1.5 to 2.5. It's a good bicycle environment. And if you see F, which is a greater than 5.5, it is absolutely unsafe environment for any bicycle user to use that roadway segment for cycling. So this is the picture that shows the different the Syncometer road, which is a 2-kilometer stretch. Since the 2-kilometer stretch is along the length, it is having a various cross sections. So we selected 4 cross sections, 4 different cross sections. Later on, that road encroachment can be done, and they can commonly space the carriageway width as well as the cycle lane width along with the walkway width with the proposal. So if you see, 4 structures are selected for the Syncometer road, and in 4 sectors we were able to do this survey, and we were able to propose a common platform for the bicycle users. You can see this picture proposed track, cycle track. Maybe I can show in the coming slides the clear picture of it, top view, then so that you can able to see that how it looks like. This is second road, which is almost 1.4 kilometers. In this we could able to select 3 different cross sections along the road, which have various carriageway widths. So we were able to propose a common proposed track for this Rajaram Sarai road, and then this is another road, race course road, which is almost 1.2 kilometers. And here we have selected 2 cross sections, and then this is another 4th road in the study area. So we have selected only 1 cross section. We noticed the entire length is of same cross section. So we were able to select the cross section to do the field survey as well as a videographic survey. And then if you see these pictures, it represents a different level of service conditions. You see this bicycle level of service here, where you can able to see different cycle lane and with the cycle lane markings. This is the best excellent bicycle environment. You can see by BLOS B, C, D, and as well as E and F. So it is the worst unsafe environmental condition, like unsafe environment for the bicycle users to ride on. And then, so these are the table result, which is mentioned the table. So we were able to find out the average daily traffic, and this is lane length, number of lanes, length, and this is payment rating condition, and then this is the different level of service scores which is obtained for different roads. And based on these obtained scores, comparing the ranges, we were able to assign the grades from the standard values. So we were able to see all the road networks which is selected for the case study are giving either D grade or E grade, which is not suitable for the cycle users with existing scenario. So here, therefore, there is a need to propose a road network where this can be used also for the non-NMT as well as MT. So with that, we developed the bicycle compatibility index. Here, we should also understand what is this BCI. The BCI is nothing but this is used to evaluate the capability of the urban or suburban roadway sections to accommodate both people, both the motorists as well as the bicyclists. So considering the operational aspect as well as the geometrical conditions. So having said that, this BCI is used to determine how compatible a roadway is for allowing efficient operation of both the bicyclists as well as motor vehicles. You see this. So basically, before going to develop BCI, we have done two things here. One is video, we have something called a video or a field survey rating scale. This rating scale is indicating the comfort level of a bicycle user. For example, you see the bicycle, suppose you are one of the person who is riding on the cycle on the roadway segment, you'll be asked to rate your comfort level on the while you are riding on the roadway segment, considering the speed, considering the value, considering the available width on the roadway segment. So based on these three factors, you are asked to write give a rate according to your comfort level. So that is the table which is represented here. So we have taken public response from the field survey as well as the video graphic survey is done. Also, we have given the video survey ratings also using this rating scale. So one indicates the extreme if the person is comfortable with the available width, with the available speed, with the available volume, he would be interested to give one. If the person is not comfortable with the available width and available volume or available with available speed, he may give 5 because he may be experiencing very discomfort. So the public opinion has taken given the ratings according to the scale which is provided in the slide. So right from 1 to 5, 1 indicates extremely comfortable, 5 indicates extremely uncomfortable. So with that, so this is how we have classified like this. Suppose you see here OFR, which is the overall field rating, OVR, which is the overall video rating. So for every parameter, we gave a field rating and video rating. So for width, we gave a width field rating. For volume, we gave a volume field rating. For speed, we gave a speed field rating. So similarly, for a video rating, we gave a width video rating, we gave a volume video rating, we gave a speed video rating. So like that, we were able to use this rating scale and give video and field survey ratings for the selected roadway segments in order to know the public response, public perception. So as I mentioned, this is a picture. This is already it's already seen. So this is already seen. So these are 4 roadway segments. So for each roadway segment, we collected the ratings from the public. So if you see this, so this is how these ratings are given considering the volume. See how could you experience considering the volume. So here, if you had experience, if your experience is worse, you can give 4. If your experience is average enough, you can give 2. So like this, the ratings are given considering the volume, speed, and width parameters for each roadway segment, and then we were able to develop a matrix model. So this is the video survey ratings, which is similar to the field ratings. Field is taken in the field. Video survey ratings are taken from the videographic surveys. So after this, we were able to do data analysis. And from the data analysis, we were able to develop the matrix tables here. The main intent to develop this matrix tables in order to find out the cohesions kappa value C, which is a K, which I'm gonna explain this. So if you see this overall field rating versus overall video ratings, so we were able to obtain the cohesions K as a 0.216. So this cohesions K, which is a statistic or non-parametric measure of the degree of agreement among pair of ratings. So I mean to say this K indicates the pair level of agreement between the field and video ratings. So this came, we were able to obtain for this overall video rating as well as field rating as 0.216. And then for similarly for various parameters like the width, volume, and speed, we were able to obtain this coefficients K value as a 0.34, as a 0.286 and 0.46. So therefore, we were able to see different things, different values of coefficients K value, indicating the pair level agreement level between the video and field ratings. And then we were able to go with the bicycle compatibility index. So if you see the different parameters involved in this model, we have a presence of bicycle lane. If you have a bicycle lane, if yes, you have to give 1. If you know, you have to give 0. And another parameter is bicycle lane width, and one is a curb lane width, one is curb lane volume. And like this, we have incorporated all the parameters in this model and developed this BCI model for all the roadway segments. And this is how this BCI range is given, right from less than 1.5 to greater than 5.30, and given grades, assigned grades from A to F, and where A indicates extremely high compatibility level for the bicycle users, as well as F indicates extremely low compatibility level for the bicycle users with the existing roadway network. So with this, we were able to calculate the bicycle compatibility index of the proposed as well as the existing roadway segments. So this is how this is the different four cross sections, four cross sections on the roadway segment selected. And this is the right side, you can see the picture, which is a proposed track with a bicycle lane as well as a sidewalk. And this is for another road, and this is for another road, and this is for another road. So all the 4 roads with existing cross space, as well as with the proposed network. And now you see the result, final result. The existing road having this BCI ranges with the different grades, and the proposed road you are having a BCI ranges, and the LO is obtained for a proposed road network. If you see this is the BCI range of this BCI values. Earlier, we have seen bicycle level of service, which is also shown D grade and E grade for a various roadway segments which is selected for the study area. And similarly, for the existing road, BCI also shown us D grade and E grade for a various roadway segments selected in the study area. So finally, this proposed roadway, we were able to improve the BCI score, and therefore we were able to improve the level of service grade from D to C, D to C, and D to C, and D to C. Therefore, we were able to understand that the proposed network can be more compatible compared to the existing road network to provide this bicycle track or cycle track. So this is the final network of that study area in KKNZ that represents this cycle track and sidewalk. So later on, to validate the result, obtain result, and to justify this proposed model, we have done the simulation part using Vision software. So we have given the data with the existing traffic and also the data for the proposed track. So if you see the picture, this is the cycle track without cycle track, the existing traffic condition, and this is the traffic condition with the cycle track proposal. So then we were able to see the difference in the delays as well as the travel time. So we have fortunately we have reduced delays as well as reduced travel time for the current for the selected roadway segment. So you see here without cycle track to reach to travel in this direction, it is taking 82.3 seconds, and therefore with the introduction of cycle track, therefore the delay is reduced to 34.6 seconds, and the travel time also taking 144. So this is how this travel time as well as delay time is reduced. Similarly, for the second road also, we were able to see the difference in delays as well as travel time with the provision and without provision of cycle tracks. So similarly, for this is another road that is also showing the improvmental condition for the bicycle users, and this is also another road that is showing the improvmental results, the improved results of delay and travel time for the road users. Also, we were able to also see there is a less number of conflicts that maybe happened with this kind of a proposed roadway, like no track road network. So coming to the conclusions, well, we have seen how this GIS and RS is applied in order to find out the hotspot regions using the IDW interpolation technique and kernel density function with the hotspot analysis. And also we have seen land cover changes. We have seen 15% incremental in urban built-up areas from 2010 to 2014, where this ultimately given chance to increase the traffic and the congestion. Therefore, there is a need to improve the traffic safety as well. Therefore, we were able to see the existing traffic situation, like the level of service for the existing road network for the bicycle users. We were able to get the results for different road selected roadway segments with a D grade and E grade, and therefore we were able to do develop matrix table in order to find out the quotient scale, which is a non-parametric value which tells the fair level of agreement between the field ratings and the video ratings, and therefore which helps us to develop BCI model for the existing roadway network and the proposed roadway network with incorporating various parameters right from bicycle lane to the payment rating condition, and then we were able to see the existing for existing roadway network, we were able to see the BCI values with the LOS, and then we were able to see the proposed BCI value, proposed networks BCI values and the improved level of service grades, and then we finally validated these results with the using by doing simulation with the help of vision software, and we were able to see the improvements in the delay as well as travel time. With this, I would like to conclude, and thanks for all your patience in listening this lecture. Yeah. I'm done. Once again, telling this is the research work which is carried way back 2010 to 2014. Since this is a program which is related to the traffic safety road, which is a part of post road safety month 2021, I just want to present something on payments, but I thought payments is already presenting by various experts. So I thought to just explain, share my experience which I had during my master's. And this was the project done during my master's, and this is the project submitted to the government of Tamil Nadu. And as a recognition, as an acknowledgement, they were able to present felicitation. They were able to do felicitation and gave award to this project for helping out in giving a proposal to develop that non-modal transport facilities in that area by the Trichinopalli Commissioner. Sir. Thank you, sir. Yes, thank you. I'm done.
Thank you, sir. Thank you for your valuable and informative presentation. Now, I request the participants to post any queries in the chat box directly, or you can directly unmute yourself and ask Mr. Girish.
Satyamurthy, sir.
Sir, if you sir, just we'll give some. Sir, there is a question in the chat box.
Yeah, I'm seeing one.
Okay, sir.
Satish Kumar has posted, is there any recent development techniques to know the question of potholes and other roads that's using RS? Is any, please tell me that it is, sir. Yeah, as I mentioned, RS and JS can be used to find out anything. Anything is possible. Even you can take the like Morning said in payment assessment, hello, you are able to hear me?
Yes, sir, you are audible.
Okay, Satish, I'm answering your question. Yeah, okay. I think Vagesh is someone who is talking. Maybe you can ask me later of this after this. So as I mentioned in the morning session by Pavani, she has done something on payment asset management. So similarly, if you see even cracks also, you can use digital image processing with this GIS can be detecting the amount of crack that is happening, the length or the depth of crack that is happening. Maybe it may be in the structure, or it may be in the building, or it may be on the pavement. And we are doing that using GIS. You can do that pothole detection. Maybe you can take images. Maybe we have something like, as I mentioned, collect events analysis. So like, because I didn't do that in using JS or RS, but there is a possibility to do that pothole detection or maybe you can see like as I said, 2010 to 2013, how it varies. Like whether you have a pothole in the year 2014 or whether you are having in 2010, you can see how it has developed from time to time. That is possible using JS by doing this layer stacking, by doing this unsupervised classification, by doing these collect events that you can, or you can even give a ratings also. As I mentioned, pavement ratings, as we mentioned, that also you can able to give. Because one of my colleague have done that pothole detection using JS, but I didn't do that. I don't have an experience, but I have a little knowledge on this.
Thank you, sir.
But very recently, one of our students have done something project on route optimization techniques for emergency vehicles. Usually we are from West Godavari district, and here in Rajahmundry there are a couple of areas where we notice the huge number of road accidents are taking place. Though we have a proper highways, but therefore there is a need to provide some routing optimization, best optimal route for emergency vehicle to serve the people at need. So people developed some routing optimization, like route optimization technique by using and developing a new algorithm, which is an anti-colony algorithm. So that route optimization also we are trying to use JS application or to apply this to identify the route optimization as well. So that is another case study that people can do route optimization for emergency vehicles. Hello? Hello? Satyamurthy sir, are you there? I think he's not there. Okay, thank you.
Participants, if you're having any questions, you can directly unmute yourself and you can ask Dr. Girish, or else you can type it in the chat box.
Which satellite is used in traffic? I'm not sure for it. We take the satellite data, as I mentioned, we took that list 3 satellite data for an area. Like that, I hope that you know that list 3 satellite data, which is a linear imaging self-scanning sensor satellite. So that list 3 data we took and we adopted that, and we did more this layer stacking. But I am not sure what satellite is used in traffic. Normally, we take, if you want any boundary map, as I mentioned, you are taking administrative boundary map for the study area, or that is what when you are about to do some traffic studies in an area, you are going to take administrative boundary map, or maybe you can go for a road map, which is from high resolution satellite imagery, which can be used to digitize different roads, that is classify different roads. So we normally use list 3. Yes, list 3. It is a linear imaging self-scanning sensor system. Because we prefer list 3 because it is having a good multispectral bands, 4 bands. So it is having good resolution, for 23.5 meters resolution, I guess, if I'm correct. So that's why I prefer list 3 data. We also have parallelly other satellite data, but I prefer list 3 because only reason that it is having 4 bands of this multispectral bands with a greater resolution, which is a 23.5 meter resolution. That's right. Yeah, satellite images, you can take directly from Google. Some things will come, but most important, this map, it is helped by NIRB people for me. But maybe possibly you will get, there is no cost for it. Yes, it is. There is no such special tools. We have a basic free software that is ArcGIS. To use that ArcGIS, that itself gives a complete solution for your problem. Maybe if you go further, AirDAS Imagine is there. That is needed to purchase a license. But for this ArcGIS, you don't need any license fees. That tool itself is enough for doing any kind of application. ArcGIS is fine. It's a free source. But whereas AirDAS Imagine that you need to purchase a license. As of my knowledge, I use these two for a kind of research. ArcGIS and AirDAS Imagine. That is two. But equally, we have other open sources as well for different analysis. We hope we will. Yeah. Thank you once again for all the participants because I was so too rushed and too heavy because I need to cover a lot of things in 1 hour. So I'm on time. So, Madam, please proceed. I just wanted to thank once again all the participants for your thorough participation for the complete week. Uh, as a part of this National Road Safety Month, our department has organized this workshop, and I see a lot of participants are familiar with us because I could see and remember you are participating in the previous events as well. So we wish to continue this collaboration in future as well. So with this, I would like to ask my faculty coordinator to proceed. Madam, please go ahead.
Okay, sir. Okay, sir. I request the participants, if you want to share anything about this webinar, you can freely share a few words.
Good evening, ma'am.
Good evening, sir. You can share.
Good evening, Palas Kumar sir, and other respective professors of Sri Vishnu Engineering College for Women. Good evening, sir, and other respective professors of Engineering College for Women for organizing and arranging such a wonderful STPV for the students and faculty members. I really enjoy this very much, sir. It's a very useful for all of us. First of all, I thank you, speakers of each every day involved in this STP for spending their valuable time in this STP. On first day, I am very sorry, sir, for not attending this session. But I really enjoyed from the second day to last is today. Last but not least, for your speech is very nice, sir.
Thank you, Satish.
Thank you, sir. I request you to do more webinars on your steel structures, sir.
Steel structures, okay. Thank you. We'll do it.
Okay, sir. Thank you so much, sir. I really enjoyed a lot, sir.
Thank you. I would also like to announce one thing for the participants. We are organizing one international conference in the month of September, 24th to 23rd to 25th of September. We'll soon release the brochure as well. The brochure will be sent to your mails as well. So kindly participate in our international conference. That is the second international conference on sustainable construction technologies and advancements in civil engineering SCTS 2021, which is an extension of SCTS 2020. Hope you are all knowing that we had successfully organized national conference of its first edition, SCTS 2020 during the year 2020 in the month of October 9th, 10th, and successfully published almost around 65 papers in IOP, Metal Science and Engineering, and Metal Study Proceedings, elsewhere Scopus indexed journals. So hopefully we would express our sincere thanks to the participants for the last previous event, and also we are requesting you to participate for our international conference, which is coming in the month of September, and soon we will release our brochure as well as website for your information. Thank you. Proceed. If at all anyone else want to share your feedback, you can.
If anybody wants to share your feedback, you can share. If not, we can wind up the session. We'll also provide you the feedback link. Just fill the feedback link and we'll provide the certificates within a week. Now, I request M. Surya Kumari Madam, Assistant Professor in the Department of Civil Engineering, SVCW, to share the word of thanks.
A very pleasant good evening to one and all. I am M. Surya Kumari, Assistant Professor in the Department of Civil Engineering, SVCW. In this evening, I feel elated to thank you all for being a part of our one-week international student and faculty development program on role of transportation engineering towards sustainable roads and traffic safety, organized in association with ICI Student Chapter from 22nd Feb to 27th Feb 2021. Contemplating the initiative of National Road Safety Month observed from 18th Jan 2021 to 17th Feb 2021. This program anchored over a substantial concept and dealt enlightening present and future generations over the demand and call for innovative research and experimentations in the field of transportation engineering for the better and sustainable society. In this regard, I mention and extend my sincere sense of gratitude to the expert forum for gracing the program. Dr. Ramesh Hus, Assistant Professor, Department of Civil and Environmental Engineering, University of Illinois, Urbana. Dr. Ayanna Habel, Assistant Professor, PDPU, Gandhinagar, Gujarat. Dr. KVR Ravishankar, Assistant Professor, NIT Warangal. Mr. Girish Kumar, SR Netherlands, Scientific Research and Data Analyst, Netherlands. KV Ratnakar Reddy, Managing Director, Infra Support Engineering Consultants Private Limited. Dr. Narasimhamurthy, Transportation and Traffic Engineer Consultant, California, United States. Dr. B. Krishna Prapurna, Associate Professor, IIT Tirupati. And finally, our beloved Dr. Palagirish Kumar, Associate Professor and Head of the Department, Civil Engineering, SVCW. And I also express my sincere thanks to Avishresh Singh and Nagashiva Pavani, scholars of Dr. B. Krishna Prapurna, for their appreciable ideas and great share of wisdom. Also, I would like to thank Sri K.V. Vishnuraju Garu, Chairman of Sri Vishnu Education Society, Dr. G. Srinivas Rao Garu, Principal of SVCW, Dr. P. Srinivas Raju Garu, Vice Principal of SVCW, and our Head of the Department, Dr. Palagirish Kumar, and convener of the program for leading, organizing, and encouraging us to be a part of the knowledge sharing webinars and programs. Finally, and importantly, I would like to place my heartfelt thanks to all the faculty and student participators because of whom we made this program a great success. Not least of all, I'd like to thank our faculty coordinator, Ms. V. Manasa Garu, for a continuous effort in the leading of the program, and all the faculty of Civil Engineering Department for extending their kind cooperation throughout the session. Bringing up the gear, I thank one and all and hope to see you all soon with many more events and programs by our Sri Vishnu Education Society. Thank you all.
Well, madam, thank you. Before going for that thing, I request all the participants to turn on your camera so that we will have a quick session. We'll take an image as our memory. So I request the participants, you can turn on your camera. We will take a picture. I request the participants to turn on your camera. I request the faculty coordinator to take the screenshot of all the participants. Yeah. So give me a moment. I'll say once again to turn off, then you can turn off. I request the participants to turn on all cameras so that we will have a couple of pictures and then you can wind up. Okay. Yeah, thank you very much once again to all the participants. The pics are done. So now we have taken. Thank you very much. Yeah, please, madam, proceed, madam.
Sir, we can wind up the session now. We'll provide the feedback link, and please provide your feedback in the link provided. Just a second. We'll provide, sir.
Madam, we'll go to the national anthem, then we'll share the feedback. Okay.
Okay, sir. Okay, sir.
We'll rise up with our national anthem, then we'll close the session.
Okay, sir.
Please play the song.
Yes, sir.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, dear participants. We'll provide the link. Just a second. We'll just provide the link, and we'll provide the certificate within a week.
Feedback is provided in the chat box, and the videos are there in the YouTube in our department YouTube channel. So once again, I'll post in the Telegram group so that you can subscribe or you can even watch that videos at any time. Thank you very much. Also, we had a previous programs videos as well in the YouTube. So if you find any interesting topics, at any time you can hear in the YouTube. Okay. Thank you.
Thank you.
Thank you all for being a part of this international student and faculty development program. If you give the feedback, you can leave the session. We'll provide you the certificates within a week.
And we request to take this as a say we request you to take this road safety month as a social movement. If there is a need for the society to improve our safety, road safety. Thank you. Thank you all.
Thank you.